There are two ways to sort arrays. The first way to sort the arrays is through what is called selection sort. And what this does is it moves through the array and continues to put pieces in the right order until it's correct. So what we're going to do is I'm going to walk you through the math first, and here's the code for it off to the right here. So we see that we have inside the code here 2 for loops, and I'll explain those for loops position-wise here in a second. And we also have a couple if statements within the for loop. So I also have an array of 5 numbers. You see that if you do it quickly in your head, that's going to end up with 19, 32, 48, 81, and 99 in that correct order. But it's not in that order right now, so therefore we cannot perform a search. So what I need to do is sort the array, and then I can search it. So the first thing I'm going to do is look here at the first for loop. It says for int equals I, so we're starting at I. We're ending, though, when it's the next to last position, the length minus 1. And the reason behind ending there is take a look at my J loop. It starts at I plus 1, so it starts one position over to the right of where my I starts. So I would be in 0, J would be in 1, I would be in 1, J would be in 2, down the line. Therefore, J checks that last position, allowing I to be the next to last position, and that way our array does not go out of bounds. So let's walk through this real quickly. This represents how our array is physically sorting, and this represents all the information. We've created 2 temporary variables, current min and current min index, that store the index number as well as give us the ability to compare the actual information. So we know that our I loop is going to run from 0 to 3. So I can go ahead and fill that in, because remember, it stops one less than the length. I is less than number of length minus 1. So it will stop at the 3. And the J will run from 1 to 4. So I can go ahead and fill that in. And then we're going to begin with checking to see our number of I and our number of J. So our number of I right now at 0 is 19. And let's go ahead, let's color code this a little bit. I'm going to make this green, and I'm going to make this guy yellow. So then we can just keep comparing down the line. I'm going over more of the theory because it's one thing to memorize the code, which you will have to do. It's another thing to look at the theory. So let's read through our loop. Current min equals number of I. So right now our current min equals 19. Our current min index equals 0. Our J number is 99. Now, the J loop runs through comparing the entire thing. So let's see what happens. For this first time, if current min, which is 19, is greater than number of J, then current min becomes number of J. And the current min index equals J. So right now, is 19 greater than number of J, which is 99? The answer, of course, is no. And it checks it throughout the entire loop. So 19 is not greater than 48, 19 is not greater than 81, and 19 is not greater than 32. So therefore 19 stays in its position. So I'm actually going to get rid of these other highlights because it checks through the entire loop. So 19 is good. 19 is going to stay there the rest of the time. Now we go to when I equals 1. And we're going to say that 1 equals 99. So this one's going to move quite a bit. And current min, therefore, right now is 99. Current min index is 1. Our J loop, I'm going to add the word starts here, at I plus 1. So our J loop starts at 48. So here we are going to have the sequence that it moves the 99 down the line. So here we go. For J equals I plus 1, if current min is greater than number of J, which it is. So here's where we have a switch. The current min equals number of J, and the current min index equals 99. So our current min is now going to equal 48, and our current min index equals 2. Here's the thing. Our loop continues to move down the line. So we were looking at 48. When we look then at the next scenario, because it's going to continue through the rest of the loop, we now look at, is 48 greater than the next I at J, because J now sits on 3. Is 48 greater than 81? It is not, so it does not change anything. But then we go to the fourth position and 32. Is 48 greater than 32? And it is. So current min becomes 32, and the current min index equals 4. So we're going to perform the swap down here. So if current min index does not equal I, 4 does not equal 1, number of current min index equals number of I. So numbers, the current min index of 4 now puts here at 32. Check that. Number of I would equal 99, so that puts the 99 at the end first. Number of I equals current min index, current min, so that makes the 32 there. And it actually, that swap right there ended up sorting out the entire array, because the rest of the time 48 is never going to be greater than 81 or 99, and 81 is not going to be greater than 99. So it takes that whole process and has to go through the rest of the array to sort it out, but it always guarantees that the next smallest number is going to end up in the next position of I. So let me go ahead and fill that out for you real quick. I is 2, which is 48, means the current min is 48, current min index is 2. J is at 3, which is 81. 48 is not greater than 81, so we can go ahead and guarantee that 48 will be there the rest of the way. And then we have 48, 48, and 2. Check that. This should have been 81, 81, and 3. Fourth position has 99. 81 is not greater than 99. We have, if I could type this morning, that would be great, our final sort. So I'm going to show you this next in the program by shuffling 5 random numbers. So we're going to take the same code in the next video and apply it.